Hi, it's Steve. I'm back again to talk about CO2 safety. As you remember from the previous session, we talked about safety and performance being two key barriers for CO2 refrigeration design. So part of the session we're going to talk about safety principles, CO2 properties, trapped liquid, system overpressure protection, pressure relief valves, compressors, and leak detection. So as far as basic safety principles, a lot of this applies to existing refrigerants. They're practices that are commonly used for installers and technicians. In this case, general instructions preventing liquid from reaching the compressor is the same as with HFCs. Liquid reaches the compressor and causes the compressor to malfunction. The PRV is unique to CO2 because of its higher operating pressures. PRV stands for pressure relief valves. Pressure relief valves are required by UL in CO2 systems and CO2 transcritical systems because of the higher pressures. So it's a common safety measure. Excessive vibration, alignment of piping, external surfaces, having corrosion protection, these are all common design practices used in different types of refrigeration, along with having personal protection equipment such as gloves or glasses that would prevent refrigerant from coming in contact with your skin or your eyes or in any place where it might have a reaction with people. The good thing about CO2 though is it's already prevalent in our a gas that's very common around us, so it's not really a dangerous material anyways. You can get CO2 on you and it wouldn't really cause a problem. As CO2 may become released due to an accident or some unforeseen situation, the change from the gas from a higher pressure to low pressure does cause it to cool off, and in some cases the CO2 could form into solids, which is the same as if you probably have seen dry ice in the past. You wouldn't want to touch it, it's very cold, it could cause some sort of a freeze burn. Typical protective gear would be gloves, glasses, and safety shoe for any refrigeration system. So again, we talked a little bit about CO2 inherently having some safe properties as a gas. It's non-flammable, non-explosive, and relatively non-toxic. So we do have a little bit of data here that tells you about the toxicity, but I wouldn't let these frighten you too much, because as it gets down to 10% and 30%, that would be an extreme amount of CO2, and these levels are much higher than levels that would cause any damage where other refrigerants you would see these sort of reactions at lower percentages of the gas parts per million. So trapped liquid is always a concern with refrigerants, in particular with CO2. CO2 has a high coefficient of thermal expansion, and it's already operating at high pressures. So what you see in the picture here is a tank of CO2 that was exploded. This is not something you're going to have to typically worry about in our systems because there's so many precautions that are built into the design. But the point is that if you have a tank that's already at a high pressure and at a temperature, and it does not have the built-in pressure relief valves and mechanisms for maintaining that pressure, if the temperature just increases because it's warming up due to the sun or because the cooling system has stopped, the pressure will continue to increase until something gives. So either the tank is going to blow up, or you have the pressure relief valves installed, or you have other mechanisms. On the flip side of that, as CO2 is released from the system, the pressure goes down, and when the pressure goes down, the temperature also goes down. This is a chart here that shows the properties of CO2, and in the freezing area here, you would have the operating CO2 as it's released could form a solid, which would be dry ice, and could cause freeze burns. So the other condition where you have the temperatures warming up and expanding inside the trapped vessels, it could expand and create higher pressures, which could also cause damage. So besides just providing the pressure relief valves in the system design, which UL requires for safety to begin with, there's also two other ways to prevent the pressure from relieving. We don't always want the pressure to be relieved through the pressure relief valves. They're only there as a backup plan. The problem with relieving that refrigerant is you can't run the system again until you recharge the refrigerant again. So two ways of handling that. are to have a backup cooling system. So if there is a power outage, you can have a generator running a auxiliary condensing unit that just keeps the tank cool. Another option is just to design the equipment to handle the higher pressures. And in that case, the pressure relief valves could be set at a higher level, or there could be low enough where both of them are just two different options for achieving the same end. So in this case, we've got some details here showing the different operating pressures of the system. We have medium temperature part of the system where the medium temp compressors are maintaining, and then the low temp, which is operating at a lower pressure. So there are controls in place that will shut down based on pressure switches, pressure relief valves that are set at the right pressures, and this keeps everything running safely through normal operation, and also provides some precautions in the case of abnormal operation. This is what the pressure relief valves look like. They're set up again, in the case of power outages or natural disasters. They have to be they can be reseated if they ever are relieving pressure. There's some details in our manual on how that's taken care of. Here we have pictures of the medium temp and low temp compressors and their typical ratings. So along with having these precautions built into the system design, it's typical to have leak detection equipment also in the machine room where the equipment's operating. So the leak detection equipment can be placed nearby the equipment, and it senses if there's CO2 present. Will send a signal to the controller and sound a horn so people will know that there's been a leak and the situation can be addressed. So once you do have a leak, the recommendation is for people to leave the room immediately, inform people in the area, and provide sufficient ventilation. Again, CO2 concentration would have to become very high, as we mentioned earlier, for it to really pose a damage. So these are just precautions that need to be taken. All right, thank you for viewing the safety portion of the CO2 refrigeration presentation. Hopefully the takeaway that you've had from this is that you've learned that the CO2 designs are safe, and they've been around for a long time. And the designs that we have in place cover a variety of scenarios to ensure that the consumers and the technicians should be safe handling the equipment. Thank you.